Hi guys, welcome to the part 2 video on the math skills on statistics. So in this video, now we are going to apply our knowledge to answer past paper questions based on statistics. So reminder, it's a high score test, students Ttest, correlation coefficient, and also standard deviation that we will be practicing now. So here we've got a question that scientists use a statistical test to determine whether there was a significant difference in the amino acids concentration in two types of white wine, and they obtain the value of P, okay, which is 0.04, and name the statistical test that scientists used and give a reason for your answer. Was there a significant difference? And give the reason for it. Name the test and explanation of the test. So 0.04 means nothing else than the 4%. So think about the diagrams that we had. 4%, it's definitely on that lower side here towards 0. What does that mean? Okay, that will mean that there will be a significant difference, and we're going to reject the null hypothesis because there is less than 5% probability that the results are due to chance. But the test that they're going to use, okay, it's a t-test. Where is this coming from? Because they were comparing two types, okay? So there is not just one case when we're looking at one thing, like when we're not tossing a coin, the same coin. Here we've got two types, okay? So t-test, because we're looking at the difference in the concentration, so in the mean of those two different types of wine, and explanation what we've said. So the difference is significant because there is less than 5% probability that the results are due to chance. Okay, so other words, they are not due to chance because it's less than 5%. Right, another question here. It's a skill to test if you can work out the high score test. So they were giving you the numbers of the different phenotypes, and what they want from you, they want you to work out the high square test. But to do so, you need to observe unexpected values. And here we've got the numbers, okay, of those phenotypes, and we can work out the total of them and then apply the ratio. So if we add 34 and 35 and 51, we are going to get 120. So this is the total. Then we're using our ratio. So the ratio would be as 1 to 1 to 2. So in total, we've got to divide this by 4. Okay, because we've got 1, 1, and 2. So divided by 4, it will be 30. Okay, so agouti stands as 1, black as 1, white as 2 in terms of the ratio. So my expected value here will be 30, 30, okay, and 2's of what I've worked out here, hence 60, okay. Then you obviously undergoing the calculations and doing this for each of the rows. So observed minus expected, okay, so 34 minus 30 square rooted divide by number of expected. So you're following this until you finish. So once you've done that, you then are going to work out the p-value for this case. In this scenario, we've got how many cases? We've got 1, 2, and 3. Okay, 3 phenotypes. So the degree of freedom, remember, it's number of cases minus 1. Hence, 3 minus 1, that's 2. Okay, so the degree of freedom that we're interested at, it's 2. And we're not looking at anything else. We don't care about any of those. So we're looking at the p-value. Now remember, p-value always corresponds to 5%. Hence, we are now interested in this column. So the p-value, okay, p-value for this is 5.99. Okay, And after you finished this, you should work out your chi-square value. So doing our calculations, the chi-square is 2.71. Okay, in this situation, we're comparing the values, not the percentage. So what we can say? We can say that chi-square is lower than p-value. Remember from the graph that we did, numbers as lowest, okay, referred closer to that 100% thing, okay, on our scale which we did. So in this situation here, there is more than 5% probability that the results are due to chance. Okay, hence you are going to accept, sorry for my handwriting, accept the null hypothesis. Okay, so there is no significant difference between the observed, because that's what we're checking, observed and expected values. And this is how we're going to write this down. Okay, so we started calculations. Obviously, I haven't finished, but if you follow everything, if you know this, then you can do everything. So the difference is due to chance, not significant, because chi-square is less than p-value. Okay, and obviously there is no significant difference. Good. So another question here. We got a table with different p-values, and the p-values were obtained shown in the table, and you need to explain what the results of those statistical tests shows. So remember, magical number, magical percent, it's 5%, and we're now comparing. So this will be 1% and 1%, so this is below. Okay, so I put below 5%. This is more than 5%. Okay, and here again below and below. So for all those below, because we remember our flow chart, we are going to reject the null hypothesis because there is a significant difference between those values, because there is less than 5% probability that they are due to chance. So there was only, okay, not significant difference using that, looking at those species. Okay, so in your answer, obviously you need to then put it in the right words. So for that species, okay, what we just were talking about, the difference is due to chance because it's more than 5%. Okay, tick. And for all of the other species, okay, it's the probability is lower than 5%, so the results are significant. So they must be definitely, they are not due to chance. Right, lovely. So another question here. So we've got the data about the length of lease in two sites to explain why standard deviation is more useful than range as the measure of variation within the population. So other words, what's the definition of standard deviation and the range? So standard deviations is the spread of data around the mean, but the range is only the difference between the highest and the lowest values. So in this situation, okay, looking at the standard, so you need to provide the definition of the standard deviation and range. So we did, and the ranges are similar in both. Okay, so so what we've got. When we work out the range of those values, they will be similar, and suggest that the variation within the population is similar, and the standard deviation is smaller with the high light intensity. Okay, so it shows that the area with highlight intensity is a more uniform population. Okay, so looking at the ranges and the differences between the highest and the lowest will be similar, and standard deviations, okay, will have the smaller in the area with the high light intensity, which we can see here. Okay, standard deviation. So the spread of data around the mean, it's here, it's